All right, so now that we've had some practice with that for when understanding whether a vector field is, or when a vector field is conservative, let's do an example. All right? So if we wanted to show this is conservative, we'd have to show that all of its components are C1 on R3 and that its curl is 0, right, by the theorem. Now, we could do that, or since we'd have to find a potential function for f at the end of the day, in this question, it's easier to just start by just trying to compute the potential. Because if f is not conservative, that's going to fail somewhere. So we may as well just start computing the potential function and go from there. If it works, hey, it was a conservative vector field. If it breaks, then okay, it's not conservative. All right? All right. So let's just kind of pretend. Let's say it's conservative. Let's try and find the potential. Right? So that would mean that this first component, and we could start with any of these three, but let's start with the first component. That means that the potential should be the integral of the first component with respect to x, right? Because that first component should be f sub x. So if we integrate this guy with respect to x, we just get e to the x sine of yz. But now this arbitrary function from before isn't just a function of y or just a function of z. It's a function of y and z. Because, well, it's something that if we took the partial derivative of this with respect to x, we should get that inside bit back. And the partial derivative of this guy, which is only a function of y and z, would be 0 with respect to x. All right. Well, now we can take the partial derivative, say, with respect to y, and set that, or well, let's find that. So that'll be e to the x z cosine yz plus g sub y of yz. Right? And we know that should be equal to this middle component, because this middle component should be fy. So we get e to the x z cosine yz. So these two guys here match up. So that tells us that g sub y is 0. All right? So then g of yz, which is the integral of g sub y with respect to y, well, that's the integral of 0 with respect to y. But since it's with respect to y and z is still hanging around, this is now just a function of z. Okay? So replacing gyz up here, we get f is e to the x sine yz plus h of z. All right? And now we just repeat this one more time, because we know that fz, which is e to the x y cosine of yz plus h prime of z, that had better be equal to this third component here, which is e to the x y cosine yz plus 3z squared. Right? And again, comparing components here shows us that h prime of z is 3z squared. So let me just say for a minute, what would it look like if f weren't conservative? Right? Because, well, okay, let's finish this, then we'll talk about that. So this implies h of z is z cubed plus some constant. All right? And we can choose whatever constant we want, since we just want a potential function. So we could use for a potential e to the x sine yz plus z cubed. This would be a potential function. So where would this have gone wrong if it weren't a conservative vector field? Well, the answer is it would have gone wrong here or here. What do I mean it would have gone wrong there? Well, what I mean is after you get rid of, on this line, the things that are the same on both sides, if there are any, then you might end up with something like g sub y of yz equals something with an x in it. That would be bad because this shouldn't have any x's. Likewise, down here, you could end up, after doing the cancellations, with h prime of z equals something that doesn't only have z's, that has like a y or an x or both, right? That's how conservativeness would break down. One of these two would fail in that way. It would have variables it shouldn't have. All right, hopefully that makes sense. All right, so hopefully all this made sense, and I'll see you in the next video.